It's March 7th, and we were finally able to image some of the Hubble 35-year anniversary challenge objects. We're in Abortal 5, and we were able to image all four of the images. We got off easy this month. They only had four objects for us to observe. And so these are our submissions for March. If you're new to the channel and don't know what the Astronomy Challenge is, I'll put a link here to some previous videos. In the description box, I'll put a link to the actual challenge so you can visit the website and learn about the challenge yourself. There's still time to do some of the monthly challenges, so feel free to join in. M44 is the first one up. It is 600 light years away. It's in the constellation Cancer, and it's an open cluster. At Messier 44, it's also famously known as the Beehive Cluster. It swarms with activity, as its name would suggest. This open cluster of around 1,000 stars, loosely connected by gravity, is one of the closest to Earth, at approximately 600 light years away. The stars of open clusters form from the same cloud of collapsing gas, and the Beehive cluster is thought to be quite young, around 600 to 700 million years old. In contrast, its Milky Way home is known to be about 4.6 billion years old. M44 was first characterized as more than a cloudy nebula by Galileo, who resolved around 40 of the stars within it. Hubble uses its high-resolution vision to focus in on sections of the nearby cluster, capturing detailed views of the bright stars mingled with an assortment of background galaxies. Our imaging of this star cluster, it looks fairly similar to the Hubble's just because that's how stars are. I just couldn't figure out exactly where they zoomed into, so I'm not entirely sure we're looking at the same spot, but I think so. So this is an open cluster, which really is just a bunch of stars. I did look for that galaxy, and I found it, and I'll enlarge that image here and point it out, but all I can see really is a fuzzy galaxy that didn't image very well yet in the sea star. We have 53 minutes of stacked exposures, so that's quite a few. So this is a pretty small galaxy in this image. Messier 48 is next up. It is 2,500 light years from Earth, and it's in the constellation Hydra. It's also an open cluster. Messier 48 is also known as NGC 2548. It's located near the head of the constellation Hydra, the sea serpent, along its borders with the constellation Monoceros, the unicorn. This intermediate-aged open cluster of around 100 to 200 core stars to as many as 1,000 members has an estimated distance of roughly 2,500 light years away. The stars of open clusters form from the same cloud of collapsing gas and dust, making them loosely connected by gravity. The historical record of M48 is the convoluted tangle of errors and rediscoveries. Charles Messier cataloged M48 on February 19, 1771, but he cataloged it in the wrong position. Since astronomers couldn't find the open cluster, it became quote-unquote lost to history and was subsequently rediscovered by Johann Elert Bode around 1782 and Caroline Herschel on March 8, 1783. Herschel added it to her catalog of objects as number 5, and her famous brother, Sir William Herschel, included it in his catalog as HVI.22 on February 1, 1786. We recorded M48 using the C-Star S50 in a Bortle 5 area. The C-Star does really well with open clusters and globular clusters, and this is no different. So M48 was captured and is beautiful. It's hard to compare them with the image of Hubble because they've zoomed into a specific area in Hubble, and I don't know exactly where that area is. When I zoomed in on the Sea Star version, I could see different red giants in different colors, but to get the whole effect of the cluster, I wanted to just show the picture of the open cluster. And I'm starting to have a fine appreciation for these open clusters and globular clusters. They're really beautiful, and I enjoy imaging them. Third in our lineup is Messier 67. It is approximately 2,800 light years away in the constellation Cancer, and it too is an open cluster. There was a theme this month, it seems. It has a handful of bright stars that are strewn across the cosmos like sparkling sequins on velvet in this Hubble image of the section of Messier 67, also known as NGC 2682, the King Cobra cluster, and the Golden Eye cluster. M67 is a collection of over 500 stars that are loosely gravitationally bound, a grouping known as an open cluster. Open clusters like this are typically quite young, but M67 is one of the oldest known open clusters at approximately 4 billion years of age, about the same as our Sun. In fact, the cluster contains about 100 stars that are similar to our Sun in composition and age, along with many red giants and white dwarf stars. It is also home to around 30 blue stragglers, odd stars that are brighter and bluer than the population from which they are formed, perhaps as a result of pulling material from a binary companion. M67 is the oldest open cluster in the Messier catalog. M67 is also unusual in its location, about 1,500 light years above the plane of the Milky Way galaxy. Most open clusters are distributed along the central plane of the Milky Way. In our version of the M67 King Cobra cluster, the Sea Star does well with this one, and it's a little bit more compact than the previous two, but it's still considered an open cluster rather than a globular cluster. It's bright. The Hubble version, it's hard to compare them because the Hubble version, they zoom in to one specific area. I also noticed that they have used star diffractor, which adds those spikes to the stars, and we did not use that in our imaging. And so both are beautiful. You can zoom in on the Sea Star version and see different colors, but I do like the look of it being the entire thing so that you can see the cluster a little better. This is the only one this month that isn't in the Messier catalog. This is Caldwell 48. It is 67 million light years away in the constellation Cancer, and it's a spiral galaxy, so it's also the only galaxy that is in this month's challenge. All the rest were star clusters. Caldwell 48 is also known as NGC 2775, and it's a spiral galaxy. This image of Caldwell 48 combines visibility, infrared, and ultraviolet observations taken by Hubble's Wide Field Camera number 3 in 2019. It features the galaxy's large yellowish central bulge filled with old stars encircling tiny wound spiral arms decorated by dark dust and a cluster of young blue stars. Astronomers use Hubble to study young stars in the galaxy's spiral arms to better understand star formation there. Caldwell 48 has an apparent magnitude of 11 and is located 67 million light years away in the constellation Cancer. It was discovered by William Herschel in 1783 and is visible in clear, dark skies using a small telescope. Resolving its spiral arms, however, is incredibly difficult, even with a large telescope. The best time of year to observe it is late winter in the northern hemisphere or late summer in the southern hemisphere. I didn't have great hopes for this one because it's so small and it's hard to get the detail on those spiral arms, but the Sea Star came through and it did image this one. I'm again imaging in a Bortle 5. So this one does depict that galaxy. It's very tiny. So I'm going to zoom out so you can see the bulge of the galaxy. So I've zoomed in on this image and cropped it down so that we can see it, but you can see the bulge right there in the center. You can see all the gases and things, but you can't really depict the spiral arms and the spiral direction of those gases flowing. All you see is the fuzziness of the gases, but man, this one's a beautiful one too. It would be one that you could probably do some post-processing on and add some color and make it look cosmic. But this one is straight off the sea star. The only post-processing I did was to darken the background so you could see it a little better. And then I cropped it down and enlarged it just so that it was more visible for the image here. But Hubble's version is certainly more beautiful, but the Sea Star did pretty good for being a tiny little telescope. So there we have it. March's challenge is complete. We need to submit our submissions to the people that are hosting this challenge, and then they will send us our certificate. If you want to join in on the remainder of the years, you can still do marches. There's plenty of time. You could send those in and do March through the end of the year's challenges. I've included the website address here. I'll also include it in the description of the video so it's more easily clickable. I'll put a link to some of the previous videos we've done about the challenge so that you can join in with us and have some fun with your imaging as well. Thanks for joining. Wishing clear skies to everybody.